Okay, so we will expand the study of circular functions by applying it to double angle and half angle formulas. Now, let's say you have tangent equals 8 over 15, and that sine is less than 0 and cosine is less than 0. That means both sine and cosine are negative, and it will refer to the third quadrant, since at the third quadrant, okay, tangent is positive and both sine and cosine are negative. Now, what is the first thing that we should do here? We need to identify what's our r, because you know sine is equivalent to y over r, okay, and cosine is equivalent to x over r. Okay, that way we can extend the value of the function using the double angle identity for sine and cosine. And so, the value of r is the square root of x squared plus y squared. Okay, we do this because we know the tangent is y over x. And so therefore, by virtue of substitution, this will be 8 squared plus 15 squared, which gives us 64 plus 225. And that will give us square root of 289. And it's equivalent to 17. So we know already what's our x, which is actually 15, our y, which is 8, and our r, which is equivalent to 17. Now, the reason why we're trying to do a double angle formula using an identity, the purpose of that is it's easy to manipulate an identity when your angle is not divided by 2 or multiplied by 2. We would like to get a single angle for our function instead of a double angle. And so we will be using this in order to substitute our values in our equation. Now, we know already the tangent is 8 over 15. And so therefore, sine is y over r. It will give us 8 over 17, and cosine is uh, 15 over 17. But we know that cosine and sine are both less than 0, so both of them should be negative. Now, the first one is you would like to find out what is the value of sine 2 theta. And we know already by identity that...
Good afternoon. Could you please release the JV football players to go to the weight room at this time? Please release the JV football players to go to the weight room at this time.
Thank you, Miss Levi. All right, so you have here the sine 2 theta is equivalent to 2 sine theta and cosine theta. And so therefore, we can simplify it with a single angle like this instead of a double angle, because we know already what's the value of sine and we know already what's the value of cosine. So therefore, this will be equivalent to 2 sine, and our value of sine is negative 8 over 17, and our cosine, which is negative 15 over 17. And so therefore, this is equivalent to, that's negative 8 times negative 15 is 120, and times 2, that will be 240, and it's positive, so 240, and we know that 17 times 17 is equivalent to 289. Okay, if it needs simplification, you need to simplify. But this is now the value of sine 2 pi, all right? Or sine 2 theta. Now, let's find what is the value of cosine 2 theta. And we know by identity, it's equivalent to cosine squared theta minus sine squared theta. Okay, we can actually use any one of these. We can always get the same answer. I'm going to prove it to you later. So let's say I will try to do it with cosine squared theta minus sine squared theta. And we know that cosine is negative 15 over 17. And then we need to square that. Minus negative 8 over 17. And we need to square that. And so you will have now positive 225 over 289 minus 64 over 289. And so if we're going to subtract this, and since we have the same denominators, it doesn't matter now. And so that will be equivalent to 25. We get 25 out of this is 39. So it'll be 161 over 289. So this will be the value of cosine 2 theta. I told you, whatever formula you will use in here, you will always get the same answer. So let's try to do 2 cosine squared theta minus 1. I will write it here. minus 1. And we know that the value of cosine is negative 15 over 17 squared minus 1. All right? And we know that this is 2 times 225 over 289 minus 1. And so that makes this 450 over 289 minus 289 over 289. And if we're going to subtract 450 minus 289, we would also be able to get 161 over 289. So whichever formula you will use, you will always get the same answer. Just follow the procedure. Find first x, y, and r. Find the values in a regular circular function of tangent, sine, and cosine. And then substitute it in the given equivalent identity of whatever you are actually looking for.